These are the titration notes. There are two parts to these notes. The first is on lab technique, and then we are going to look at calculations. For the calculation portion, it'll be helpful to have your periodic, not your periodic table, a periodic table for writing equation or reactions, your formula sheet, and a calculator. All right, starting with our lab technique, what is a titration? A titration is a technique where a solution that with a known concentration is added to a solution with an unknown concentration in order to until an equivalence point or neutralization has been reached. Our goal is to determine this unknown concentration through that neutralization reaction. And how we're able to do this is with an indicator to show where that neutralization is taking place, because normally if you're just combining two solutions, we most of the time cannot see differences in an acid and a base. And so to get that neutralization, we need the neutralization reaction, which so we need our balanced reaction. And while an acid only donates one hydrogen ion at a time, it is going to donate all of its hydrogens through that neutralization reaction. And so we are going to use that as just a double displacement reaction. With this setup, we've got a burette, which is a graduated glass tube filled with a known concentration solution. And that allows us to measure after we've dispensed, since we don't know how much we're going to need. We are going to use basic solutions with a known concentration in our burette, but you could, if you know the concentration of an acid, you could put an acid in your burette as well. The stopper here allows you to dispense the solution quickly or in small increments. And then in our Erlenmeyer flask, this is filled with a measured amount of a solution that we do not know the concentration of. We are going to put our acidic solutions in there, and then we put indicator in there. That's going to help us determine when we have reached neutralization. And the Erlenmeyer flask, the shape of that helps so that we can easily swirl and mix that without any of our solution getting out. Reading a burette is a little different than reading a normal Erlenmeyer flask. 0 is at the top, and instead of measuring how much, we measure how much is in the burette along the way, and then we subtract to find out how much is used. So 0 milliliters is at the top. You are going to read down from that to the level. And so your values should start with low levels, and then as you add more, your readings should get larger. We are going to estimate 1 digit past the gradations. And so if you see on here, we have digits markings at the 10th. And so the reading is 0.27, estimating that digit past the 10ths. If it is an exact value, you would put a 0.00 to show that and record that on your data table. Our burettes hold 50 milliliters. They have the same markings as these, but they go up to 50. And so with markings at every 10th, all of your digits or everything that you record should have 2 decimals. And so then to find volume dispensed, we take an initial reading. So in this case, that initial reading is showing 0.27. And we're going to end up subtracting that from our final reading. So final volume 2.65 minus that 0.27 gives us the volume that was dispensed throughout that titration. Looking at some practice of reading these, so let's determine those volumes. It is a little different because we are reading our numbers down instead of reading up like we normally do with a graduated cylinder. With this, we are looking at the meniscus, so to the bottom of that line. So as I look at this and as I am putting my line here, it does look like it's a little bit right on the line. And so if I say, yep, that is exactly right there, then this would be at 8. This is 8.5. So this would be at 8.6. If I think it's right on the line, I need to say 8.60. My final volume then, doing the same thing, I can have that line looking at the meniscus, the bottom. This one though looks like it is not quite halfway in between. And so I can see here, this looks like we've got our 33, here's 33.5. It looks like it's not quite at 33.6, so I'm going to say 33.55 for my final volume. So how much base was added if these are my starting and final volumes? Well, we would go 33.55, subtract off that 8.60, and so the amount added would be 24.95 milliliters. Try the next one on your own if you want, or you can do it with me. Again, with these pictures, it's kind of nice to do a line to just kind of see where is that meniscus at. You don't have to do that. This one to me looks like it is not quite at that 0.1 line. It looks like it's a little bit below. And so I'm going to say that maybe this is at 0.1 and it's just past that. So 0.12. And then here we've got our, looks like we're not quite at 12. So it looks like I'm just kind of above that. So I'd say I'm at 11.9 and then I'm pretty close to being right at that 12, not quite halfway. So I said 11.97. And then finding how much is added, we go final minus initial, 11.97 minus 0.12. Remember, subtracting rules, we do digits after the decimal. So we shouldn't lose any of our exactness because we have 2 digits after the decimal and 2 digits. And so we still have those 2 digits for our amount added. All right, so when do we know when to stop titrating? We are going to use an indicator. We often use phenolphthalein, and it talks about that a little bit down here. And so when we have a pH that is going to be increasing, and so here this is showing that I have an acid. So we are going to have acid in our beaker, and then we put that indicator in. So acids, those have a low pH. As this pH increases, then we're going to start to see this solution holding on to the pink. When this is at neutral, which would be a pH of 7, and before this was, let's say, a pH of less than 7. So less than 7, if it's acidic, we should have a clear solution. If once we get to neutral, that pH of 7, that is showing us we have that neutralized reaction, which is our goal in a titration, is to get something that's neutral. If we have something that is basic with a pH of greater than 7, we're going to see a dark pink. So our goal is a good pink or this neutral, very light pink. And so a good pink shows us a neutralization reaction has occurred. The acid has neutralized the base and vice versa. You have just barely pink, which is why we put these on white pieces of paper to make sure we can see that hint of pink. So extremely pale rose color. And when you swirl the flask to mix those, it's going to stay barely pink. If that pink goes away, that means that we are not quite at that neutral. And so bad pink would be when the reaction is not neutralized. So we either have more acid or more base. That could happen in 2 ways. If you have a dark pink, bright color, that means too much base was added. You would have to start the titration again. And sometimes it will lighten, so give it a minute of kind of stirring it up, swirling it. But if it does not lighten to that extremely pale pink, you need to start again. But if you are swirling your flask, mixing it, and that pink goes away, that means we're still acidic. You need to add a drop or 2 to try and get to that neutralization point. And when we get to that point, that's when we would take our measurements to say, okay, here's our final volume. This is the end of the titration lab techniques notes. Head to the next video for the titration calculation video.